tell us, right? This is basically like what we just said. Let C be a positive real number. Okay, so if C is just any number, then this is kind of flipped from what we saw in our exploration, but if it's inside the parentheses, then it's moving it left and right. Something else you should have noticed is that it's moving it opposite of what you would think, right? To the right is usually our positive numbers, and to the left is usually our negative numbers. But this is flipped. If it's negative, it's going to move it to the right. And if it's positive, it's going to move it to the left. Okay, so again, it is that those horizontal ones are a little bit flipped from what you would think. Versus our vertical translations, again, those things are like outside of the function. We didn't have to have parentheses for them. When I add, it does move up, and when I subtract, it does move down. So your vertical is more what you would expect. Okay. And the big thing here is this is just any function. I can give you any f of x. I can make f of x equal to anything I want. And then if I change it in these very little ways, it's going to be the same idea. It's going to shift it in this manner. Okay, so it doesn't matter what our function to start with is. So let's look at some examples. Example 1, describe how the graph of the given equation has been transformed from its parent function. So the first thing we need to know is determine what is actually the parent function. So if I look at A, y equals, well, remember, straight up and down lines, those are absolute value symbols. So absolute value of x minus 4. So our parent function here is the absolute value. And how is this shifting? Well, this minus 4 is outside of the absolute value. So it's outside of that function. So what that minus 4 is doing, when it's outside, it's either going up or down. And since it's negative, it's going down. So this is going to shift down 4. Same idea with our b here. Y equals e to the x plus 2. Well, then we want to know what our parent function is. Well, e to the x plus 2. E is just a number. It's kind of like pi, right? But e is its own number. It's 2.7 something. So this is e to the x plus 2. My x is in my exponent. So when your variable is in your exponent, it's called an exponential function. So this is our exponential. And then how is this moving? Well, we have this plus 2. And we want to think about what that plus 2 is doing there. Well, the plus 2 is part of my exponent as well. So you can think of it as being inside your function because it's inside that exponent. Inside moves it left and right. And it's always opposite of what you want it to be. So you're adding, so you would think positive, so it's going to go the opposite way, right? So it's actually going to shift it left 2. let's look at our example 2. Write the equation of the function after the given transformation. So reciprocal, shift up 3. Okay. So this is our parent function, reciprocal. So I want to first write f of x equals 1 over x. That is our reciprocal parent function. And then I'm shifting it up 3. Well, then up and down is outside of our function. And up would be plus 3. So I'm basically going to do just this. I'm going to take my f of x, which is 1 over x, and add 3. The hair keeps hitting the board when I turn around. So that is my answer. So my new function is f of x, or really that 1 over x plus 3. That is my new function. B, logarithmic, it's going to shift right 1. Well, again, my parent function is f of x equals the natural log of x. And we'll learn more about logarithms in our later unit, but as long as you know what the parent function looks like, you're good. So ln of x. So it's shifting right. Remember, right and left is happening inside my parentheses. And inside, it's opposite of what you think. Right is usually positive, so it's going to be minus. And then I'm going to do the same thing here, the natural log of x, and I'm also going to do minus 1. Okay, so doing these transformations is very similar to our function notation that we looked at in target or section 1.4. Okay, I've changed x to x minus 1, so in my function I changed x to x minus 1. Right, C, cubing function, and I want to shift down 2 and shift left 4. Okay, so my cubing function is f of x equals x cubed. Okay. So I'm doing 2 things here. One, I'm shifting down. Second, I'm shifting left, right? So I have something happening inside my parentheses and outside my parentheses. So f of x, well, the shift left is going to affect inside my parentheses. Inside, so it's opposite. Left is usually negative, so we're going to do the positive. And then we have this down 2. Up and down is outside. Outside is what you think. Down is negative. So it stays negative. So we have f of x plus 4 minus 2. And that is going to equal, well, I'm just going to replace my x with x plus 4. And then I have it cubed.